What's up, y'all? We're going to evaluate the integral of e to the negative tx sine of x from 0 to infinity, where t is any real number. And this is going to be awesome. This is my favorite, easiest method to do this. Normally, this is done using integration by parts, but we're going to do a much easier way, and we're
Woohoo!
going to use Euler's formula. Now, hang in there. Trust me, it is very easy to do the integral if we do this. So the sine of x is the imaginary part of e to the ix. So we're going to substitute that into our integral. So it's the imaginary part of the integral of e to the negative tx of e to the ix dx. So if we make this substitution, we can merge these powers together by adding the exponents, and we can celebrate because this is a fun integral to do. This one's hard, but now we've made it easy, and it's the imaginary part of e to the negative t plus ix divided by I minus t from 0 to infinity. Now we need to deal with this imaginary part and then evaluate it as well. We're going to substitute back from Euler's formula to give us the sines and coses at 0. In the limit as x goes to infinity, this goes to 0. And I hope you can see that because there's a negative sign. So no matter what t is, if t is any number, as x goes to infinity, it's like this exponent's in the denominator, so this goes to 0. And if we plug in 0, this is 1, right? Cos of 0 is 1, and sine of 0 is 0. So this whole thing becomes negative 1, okay? This whole thing becomes negative 1. So that's not too bad. Imaginary part of I divided by t minus I. Now here I have I minus t, but see there's a negative here, so I brought this negative into the denominator to make it t minus I. Okay, now last part is to deal with the imaginary part. How do we extract the imaginary part out of this? Well, we need to put it in the form of a plus bi, where a is the real part and b is the imaginary part. So we got to find out what b is. So we'll take this fraction, we'll multiply the top and bottom by the conjugate, and knowing that I equals the square root of negative 1, so I squared equals negative 1, this simplifies to t plus I divided by t squared plus 1. And we can split this up, this fraction, into two fractions with the common denominator. And here, my friends, we have the two parts. This is the real part that we don't care about, and this is the imaginary portion b, which is the answer to our integral, which is what we want. Just as a note, this real part, this is our answer if we had a cosine here in the integral instead. So just kind of as a bonus, we get another integral out of it. The integral of e to the negative tx cos x from 0 to infinity is, in this case, it's the same, but it's not always the same. It's the real portion of this integral. All right, y'all. I hope you enjoyed it. It's way faster than integration by parts. Good luck on your midterms, final exams, and you can survive.